Everything in the body from enzymes to muscle fibers begins with DNA. In this video, I'm going to show you how a cell uses the instructions in DNA to create the proteins it needs in Minecraft. Okay, let's look at DNA first. So this is what's meant to look like a double-stranded DNA molecule. Every strand contains a complementary bases where A pairs with T and C pairs with G. To be fair, DNA just looks like a ladder, but with its double helix. Alright, so basically the first stage is transcription, which happens in the nucleus, which is where our precious DNA is all together. Okay, we're gonna get ourselves an enzyme called RNA polymerase. As you can tell, it has split the DNA in front of it, exposing the bases. This will then help make the mRNA, which is complementary to DNA. Okay, this is gonna be our mRNA. So as you can see, C connects to G, T connects to A, and this one over here is A, but because there is no T in mRNA, so instead we're gonna get uracil instead of thymine, and simply G with C. So an A on DNA is complementary to a U in mRNA. The RNA polymerase would keep moving throughout the DNA until it has finished making its mRNA strand that we want to copy. To keep the DNA intact, as it moves, it starts separating as well as closing. And when it's done making the mRNA strand, it leaves, letting it close up. Now, the DNA is actually too big to leave the nucleus, so the mRNA are able to squeeze through to leave and enter the cytoplasm. Now moving forward to translation. So we have our mRNA, which is a copy of a gene, as well as our cytoplasm. Now just outside the nucleus we have ribosomes, which our mRNA heads to. Both DNA and mRNA have codons. This is codes for a amino acid, as there are 20 amino acids. So in this mRNA there is meds and ARG. This individual one is tyrosine, which you can see is U, A, and C. Now let's see closer with a ribosome. As you can see, tyrosine is the first one it will translate. This will represent our ribosome as they bind together. Now as it moves, it slowly adds one amino acid at a time. Now don't forget, this is a tRNA, as the T stands for transfer, as the amino acids at the top and the anticodon is at the bottom. Now this tRNA will find itself to its complementary code. As I said before, it was the first one. Now as the amino acids from the tRNA connects together in the right order, it chains together as the ribosome goes through, detaching the tRNA molecules. So after the ribosome joins them together with peptide bonds, this creates a growing peptide chain. As they detach, they can fold up on itself and make a protein.